So hello everybody, back again. So in this class we are going to discuss about the critical angle of propagation. Then we'll discuss what is acceptance angle, what is acceptance cone, what is numerical aperture, what is fractional refractive index change. That is some of the technical terms that is associated with optical fibers. So these are the portions that we are going to cover in this class. Okay, so first we'll start with this critical propagation angle. Okay, so consider a step index fiber. So now we are assuming a step index fiber. We are going to draw a step index fiber. First we'll draw the We're going to draw the step index fiber. Okay, this is the core. Then we'll draw the cladding. This is the core, the inner region, and we'll draw the cylindrical part here. Okay, so this is the core region. This is the core region, and this is the what I'm drawing now is the cladding region. Okay, this is the core region. I'm drawing only a single portion of it, and while we will be having the axis of the fiber, I'll change the color of the axis of the fiber. That is line which is drawn from the center of the fiber is called the axis of the fiber. This is the axis of the fiber. This is the axis of the fiber. So normally I'll assume a portion also which is called the cone. Okay, there is a cone here. Sorry. Okay, I'll finish off the picture first, then we'll discuss. Okay. Okay. We'll finish off the cone first. Okay. Here there is a cone assumed. Okay. Now what happens? Suppose we are having this is the this is optical fiber, and this is having core of refractive index N1. We are having core of refractive index N1, and cladding is having refractive index N2, and N1 is larger than N2. That you know already. Now we are having a ray. Suppose we are having a ray which is entering to the core region. But what happens? It is making an angle theta. Okay. It is making an angle theta with the axis. It is making an angle. Actually, this is the axis of the fiber, and it is making. Suppose it is making an angle theta such that it makes an angle theta here. This is the angle. Okay, this is the angle made here, and this angle I'll just name it as theta. Okay, I'll just name it as theta here. This is the angle. Okay, sorry, name it as theta here. This angle is called theta. Okay, this is called theta. So what happens? Okay, and here let us consider step index fiber. This is a step index fiber, and the refractive index of the core N1 is greater than that of cladding. There is a step continuity at the core cladding interface. The end at which the light enters the fiber is called the end at which the light enters the fiber is called the launching end. This region is called the launching end. Launching end. This region is called the launching end. And what happens? In a step index fiber, the refractive index changes rapidly from the core to the cladding. And now consider two rays which is entering the fiber at two different angle of incident. And here we assume the first ray making an angle theta with the axis. With respect to the axis of the fiber, the ray undergoes refraction at the point A, and I'm going to name this as the point A. I'm going to name this as the point A. This is the point A, right? This I'm going to name as point A, right? And what happens? A light ray which is traveling at an angle theta with the axis. Once it enters the fiber, I'll have to make the ray path. I'll have to choose the ray path again to be violet. And what happens? It goes straight away. It does not satisfy the condition of total internal reflections, and it gets scattered away. It gets scattered away from the fiber. Okay. And this ray is called a unguided ray, and this ray which is scattered away or refracted away from the optical fiber is called a unguided ray. Such rays are called unguided. Now what happens? There is another ray. I assume another ray. What? This ray is, I assume another ray, and this is that ray. Okay. This is the ray which is traveling. The ray which is traveling along the cone. Okay. What happens to this ray? This ray which is traveling, I have drawn a cone, and the ray which is traveling along the surface of the cone means what happens? It enters at a particular angle, and this angle is called the for time being I'll name this angle as theta r. I'll name this angle as theta r, and the angle of incidence, and I'll name the angle of incidence as theta, and this angle I'll name this angle as theta now. Okay, this is my angle of incidence, that is theta. This also was theta, and here I'm going to name it as theta. And the ray which is making, which is along the surface of the cone, what happens? It makes an angle theta r, and it undergoes the total phenomena of total internal reflection. It undergoes the phenomena of total internal reflection, and the ray path got guided. And the ray path undergoes complete reflection, and it is guided. And such a ray is known as what? Such a ray is known as, this ray is known as a guided ray. This ray is known as a guided ray. This ray is known as a guided ray. Okay, right. Okay. And this angle that is the ray which is undergoing total internal reflection makes an angle at the core cladding. I mean, it should make an angle at the core cladding interface. So what I've drawn is, okay, what I've drawn here, okay, some, okay, a small mistake occurred here. Okay, here it should reach at the core cladding interface. What I drew was not like that. Okay, what I drew was not at the core cladding interface. That was the problem actually. Okay, now it's clear. And this, okay, this ray will get guided. This ray will get guided within the and this ray is known as the guided ray. I'm not going to write it again. This ray is known as the guided ray, and as usual it makes an angle. It makes an angle theta here. It makes angle theta here. It makes angle theta r, and I'll have a normal here. Suppose this is the normal, and this angle is known as the phi c. Okay, this angle is phi c. This angle is phi c. So what I'm going to do is I'm going to name this point as B. Okay, and here it is A. This point is B. So this point is, I'm going to name it as C. Okay. Okay, this point is C. This angle is phi C. This angle is theta R. Okay, so it is clear. Okay, so at the point B, at the core cladding interface, the ray undergoes total internal reflection as N1 is greater than the refractive index of the core. N1 is greater than that of the refractive index of the cladding. Let us assume that the angle of incidence at the core cladding interface is phi C, and this phi C is called the critical angle. And this phi C is called the critical angle. Critical angle. Okay, critical, and this angle phi C is called the critical angle. Phi C. This is the critical angle, right? Okay. So let us assume that the angle of incidence at the core cladding interface is the critical angle phi C, and this critical angle phi C is already given by what? Critical angle phi C is sine inverse N2 by N1. Okay, and we know sine phi C is what? N2 by N1. Sine phi C is N2 by N1. Is the refractive sign of angle of at a critical angle. What happens? We have discussed in the last class, in the last video lesson, the critical angle is given by phi C. The critical angle phi C is given by phi C is equal to sine inverse N2 by N1. Sine inverse N2 by N1. Sine inverse N2 by N1. Okay. A ray incident with an angle greater than phi C. A ray which is incidenting at an angle greater than phi C will be confined to the fiber and propagate in the fiber. A ray incident at the core cladding interface at a critical angle or at an angle greater than critical angle will be propagated through or guided through the fiber. and such a ray which satisfies the condition of critical angle and above is called the critical ray. The critical ray, and normally the critical ray makes an angle theta c. And when this is a critical ray, this angle of refraction theta r, I have already mentioned it as theta r, which was the refracted ray, will be equal to theta c. When it is critical ray, this angle become theta c. Okay, this theta c. So at this critical, when the critical ray makes an angle theta c with the axis of the fiber, it propagates through the fiber. When theta is equal to theta c, what happens? The rays propagate through the fiber, and this is the theta r. Okay, this angle, and this angle is the phi c. Okay, so it is obvious that the rays with propagation angles larger than theta c will not propagate through the fiber. The rays with angles greater than phi c will propagate through the fiber. The rays with an angle greater than theta c cannot propagate through the fiber. Then the theta c is called the critical propagation angle, and this theta c is called critical propagation, this angle. What happens? It is understood from the figure itself. When theta c increases, normally this is 90 degree, and phi c increases, what happens? Theta c will decrease, right? When theta c increases, what happens? Phi c have to decrease. When phi c decreases, the condition of total internal reflection and all won't be satisfied. Hope that is clear. This is the critical angle, and theta c is the critical propagation angle. Theta c is the angle that the ray makes with the axis. This blue line is called the axis of the fiber. The ray which is entering the fiber make an angle with the axis of the fiber. Such a angle is called the critical propagation angle, and the critical propagation angle should be always less than theta c. What happens? When theta c increases, phi c should decrease. When phi c decreases, the condition of total internal reflection won't be satisfied. So I can say it is called the critical propagation angle. Critical propagation angle. Critical propagation angle. Okay, critical propagation angle. Okay, hope that is clear for you. Okay, and from triangle ABC, you assume the triangle ABC. This is A, this is B, this is C. Angle A is theta C, angle B is phi C, and angle C is 90 degree. What I can say? Sin phi C. What I can say? What I can say is what? Sin phi C. Sin phi C is what? Sin phi C. Sin of phi C is opposite. Opposite is what? AC. Hypotenuse is AB. AC by AB. And what is cos theta C? Theta C is this angle. Theta R becomes theta C. So I can write cos theta C. Cos theta C. Cos theta C. Phi C was this angle. Phi C was this angle. And theta C is this angle. This region. This angle is theta C. And what is theta R is equal to theta C? It is adjacent. Adjacent is again AC. Hypotenuse is AB. AC by, I can write as AC by AB. So both sin phi C and cos theta C is equal to AB. Sin phi C is equal to cos theta C. So I can write sin phi C is what? N2 by N1. So cos theta C also equal to N2 by N1, or I can write theta C is what? Theta C is equal to sin inverse N2 by N1, and sin phi C is equal to cos theta C. Theta C is also becoming cos inverse N2 by N1. 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 Thus only those rays which are refracted into the cable at angle theta r, which is less than theta c or equal to theta c, will propagate through optical fiber. All angles greater than theta c won't propagate through fiber. It will be, that is, this rays. Greater than theta r means it will be refracted away from the fiber. All rays which is traveling with angle theta c is less than angles less than theta c or equal to theta c will travel through the fiber. All angles greater than phi c undergoes total internal reflection. So, hope it is clear for you. Critical angle of propagation theta c. Okay. So, next we will discuss again acceptance angle. Let us again consider a step index. Let us again consider a step index optical fiber into which light is launched at one end. And the refractive index of the core is, as we have mentioned earlier, refractive index of the core is what? N1, which is greater than that of the cladding, which is N2. That is, N1 is greater than N2. And light is traveling from air. Air is having a refractive index N0, and it is normally taken as what? Okay, air is having a refractive index N0. Assume that the light ray enters the fiber at an angle theta I to the axis of the fiber. So I'll name this angle. That is the angle with which the light ray enters the fiber. This angle. Okay. This is the angle with which it enters the fiber, this angle. And normally I'll name it as theta I, angle of incidence, that is theta I. Okay, theta is the angle with which it enters the fiber, that is, which is actually on the surface of the cone. And those rays which will be on the surface of the cone or inside the cone only will be propagating through the fiber. Others will be, what happens, will be refracted out. And it strikes the core cladding interface at phi. Okay, I have written it as phi c, or I can name it as phi. Okay, in the special case, angle of incidence, and here the refracted ray is, incident ray is theta I, refracted ray is theta r, and this angle is, I can name it as phi or phi c, or I name it as phi c. Okay. So, by Snell's law, what I'll get? Sin theta I. From Snell's law, what I'll write? Sin theta I by sin theta r is equal to what? Sine of angle of incidence to sine of angle of refraction is what? This is N1 and N0. Light refractive index of core is N1. And it is traveling from air to core. The refractive index of air is N0. As theta I is increased beyond a limit, what happens? Phi will get reduced and the ray escapes from the fiber. Okay, that is well understood from the last class. And what is sin theta r? And what is this angle theta r? I can say, if we assume the triangle ABC, what I'll get? From triangle ABC, from triangle ABC, what you'll get? From triangle ABC, theta r plus phi c, theta r plus phi c plus 90 is equal to theta r plus phi c plus 90 is equal to what? Plus 90 is equal to 180 degree, right? Theta r plus phi c plus 90 is equal to 180 degree. From this I can find out theta r. What is theta r? 90 minus phi c. From this equation, theta r is what? 90 minus 90 minus phi c. 90 minus phi c. 90 minus phi c. So what is sine 90 minus phi c? Sine 90, sine theta I by sine theta r is n1 by n0 and theta r is 90 minus phi c. Sine 90 minus phi c is cos phi c. So if I am writing sine 90 minus sine theta r is what? If I am writing sine here, sine theta r is equal to sine 90 minus phi c is equal to cos phi c. That is equal to cos phi c. That is equal to cos phi c. So from this equation, instead of sine theta r, I can write cos phi c. So sine theta I is equal to sine theta I is equal to sine theta I is equal to what? From this equation, instead of sine theta r, I am having cos phi c. n1 by n0 into cos phi c. Just write it down, n1 by n0 into cos. Hope you are writing along with me. It is n1 by n0 into cos phi c. n1 by n0 into cos phi c. So what you have got the equation? Sin theta is equal to n1 by n0 into cos phi c. Just note it down. Sin theta is n1 by n0 into sin theta is n1 by n0 into cos phi c. Okay. And at critical angle, that is when at critical angle of propagation, what happens? Our ray will be propagated through the fiber, and that is sin theta I. And when phi is equal to phi c, theta I is the maximum angle. So I can write it as sin, instead of theta I, I'll write sin theta max. That is the maximum angle of incidence possible at which the ray will be propagated within the fiber. That is sin theta max. Sin theta max. Sin theta max is what? As I have written before, sin theta max is n1 by n0 into cos phi c. Sin theta max is n1 by n0 into cos phi c. Okay, hope that is clear for you. I'll take one more page, then only it will be clear for you. Okay, or I'll continue it here. And we already have what? Sin theta max is n1 by n2 into cos phi c, but we already have sin phi c. Sin phi c is n2 by n1. From that I have found out cos phi c. Cos phi c is what? Sin phi c is n2 by n1. Yes, it is written here. Phi c is equal to sin inverse n2 by n1. And from that I can find out cos phi c. Sin square phi plus cos square phi is 1. So cos square phi is what? Cos square phi is, I can substitute for sin phi. Sin phi is, sin square phi is n2 square by n1 square. So it will be 1 minus n2 square by n1 square. Or I can write cos phi c as, cos phi c as cos phi c is equal to sin phi c is n2 by n1. Sin square phi c plus cos square phi c is 1 From that I can find out cos phi c. Cos phi c is what? Root of n1 square minus n2 square divided by n1 that is cos phi c is what? N1 root of n1 square minus n2 square divided by n1. And now what you have to do is you have to substitute for cos phi c in the first equation for sin theta max. You just note it down. Cos phi c is root of n1 square minus n2 square by n1. So what I'm going to do is I'm going to make a substitution for cos phi c in the equation that we have written before, and our equation thus becomes sin theta max. Theta max, that is this theta, this angle of incidence is the maximum angle. Sin theta max. Theta max. I'll write it here. We already have it to be sin theta max is equal to what we are having. It is n1 by n0. n1 by n0 into cos phi c. And we have found out what is cos phi c. It is what? Root of n1 square minus n2 square by n1. So what is next? n1 and n1 get cancelled. So what is left is root of n1 square minus n2 square by n0. n0 will be normally for air, n0 will be 1. So what I'll be having is sin theta max. Is sin theta max is what? Root of n1 square minus n2 square. Sin theta max is root of n1 square minus n2 square. From this I can find out theta max. Theta max is sin inverse root of n1 square minus n2 square. So this angle is called the acceptance angle. This theta max, the angle theta max, which is sin inverse root of, just put it in a box, sin theta max is equal to root of n1 square minus n2 square, or theta max is sin inverse root of n1 square minus n2 square. And this angle, which is actually the angle of the cone, and it is called the acceptance angle. The angle theta is called the acceptance angle, or theta max, or theta 0, or theta I is called the acceptance angle. It is the maximum angle that a light ray can have relative to the axis of the fiber and propagate easily without any leakage through the fiber. Thus, only those rays that are incidenting on the face of the fiber making an angle theta max, or making an angle theta max or less than theta max, will undergo total internal reflection. Only those rays making an angle equal to theta max or less than theta max, that means those rays which are entering within this cone will propagate through the fiber. So this region, this cone is called the acceptance cone. The angle of acceptance cone is twice theta max. Hope it is clear for you. Hope that is clear for you. So we'll have 2 more portions related to it: fractional refractive index change and numerical aperture, that you will discuss in the next class. Fractional refractive index and numerical aperture. It's already running out of time, so we'll discuss it in the next class. We'll finish off this chapter with by next class. Okay, so thank you. If you go through your textbook, write down the notes. If you are having any doubts, come to me, discuss with your friends, and you can ask me also. So thank you.